All right. Hello, guys, and welcome to IV Tutor. We are looking at linked lists in this video. And again, this is exam preparation. So you should really revisit, the videos that we talk about or the lessons that we did on linked lists that are more detailed. But here we are going to do a quick recap on linked lists, starting off with nodes, understanding what nodes are and how linked lists work. And then we will look at a few past exam paper questions and see how we go. So basically, when you talk about a linked list, we are talking about a collection of items, right? So the same way you can have a collection of items in an array, that is the same way you can have a collection of items, this time in a list. So a list is made up of what we refer to as nodes. So these here would be nodes, right? And these nodes are connected together. So if we draw this as a diagram, they would look like what you see here, which means this node connects to this node, which connects to this node, which connects to this node. So basically, that is how a linked list looks like. It's a combination, it's a collection of nodes that are linked to each other. And each node is basically made up of two parts. The first part being the value that it stores. Like in this case, we can simplify this diagram and simply say that we've got a list of numbers. The first one being 17, which links to 92, which links to 63, which links to 45, which is the last node. So if I draw a simplified version of our list, it just looks like this, right? But then the question becomes, what are these weird numbers that we see in this example here? So basically a node is then made up of two parts because each node needs to link to the next node. So we've got the actual value for that node, and then we've got the link to the next node, which means each node carries two items or two types of items. The first being the value, the second being the link to the next node. The value doesn't have to be one item. I'll explain this. But basically that's a node, which means what you are seeing here is that this node has a value of 17, and it's pointing to this node, which has a value of 92, but is sitting at this address, which means what we're referring to as the link here is simply the address of the next node. Because remember, everything that is, memory has an address of where exactly it is. So what we are basically saying here is that this node is at address 2800. Therefore, this node stores the address of the next node, which is 2800, which is equivalent of simply saying it links or it points to this node. This node 92 points to this node 63, which is at address 1500, which means the link or the address inside this node is the address of the next node. So basically, we can then simply say that each node stores its value and the address of next node. So what we have here is address of next node, and this is the value of the node. And the next question becomes, what is this info that we see here? We'll talk about that very soon, right? It's basically just this value here. So what about this head? This is also a pointer, which is saying, well, the address of the first node is 2000, okay? So this diagram gives a very simple illustration of how a linked list looks like if we had to draw it like in a straight line. But the main concept to remember is that each node stores its value and the address of the next node. So diagrammatically, this is what it looks like. But what if we are writing code? What is this thing that we are calling a node? So a node is basically a struct, right? And this is based off our recommended textbook. So all the nodes that we use and all the class names and the types that we are talking about here are based on the recommended textbook on this module. Therefore, this is how everything is defined. So a node is made up of a struct. So a struct is the basis, or actually a struct here defines our node. And our node is defined as a template because we want our nodes to be of any type. So if we go back here, we can see that we've got a list that stores integers. But what if we want our list to store doubles or strings, right? It means it has to be flexible. So to achieve that, it means that our struct is defined as a template, right? And now you see why here we use the word info. This is based on the way a node is defined in our textbook. So info is representing the value that is being stored by the node. So it's stored in a variable called info, right? That's the value. And then link represents a link to the next node. Now remember that the link is storing the address of the next node. And we know that if you want to store the address of anything, what do you use? A pointer, which means our link variable here is actually a pointer. That is why you see this asterisk there, right? But remember, every time you define a pointer, it also needs a type. For example, if I've got an integer y, and I want to define a pointer that stores the address of an integer, I would define that pointer like this, for example, right? I'll just put this asterisk here. I'll put a type, which means this is a pointer of type integer. In other words, it's a pointer that stores the address of an integer. Now, if we come back to our struct, we want to store the address of the next node. The next node is of type node type. Because remember, all nodes are of type node type. Therefore, we make a pointer of type node type, which is a template. Therefore, is to put type, and we put our asterisk, which shows that this is a pointer. So eventually, you're going to realize that our node is made up of two attributes, info and link. Info being the one storing the value, which means it's of type, whatever type your node is. If we want a node of type integer, we would then define that as node type of type int. And we can call this one n. That is how you then define a node of type int. Why do you have to do this? Because it's a template. So there are two attributes in our node. Number one, info, which is of type because this is the actual value, and a link to the next node, which is a pointer of type node type. All right. So if we then move on, you're going to realize that this is basically a simplified diagram of our nodes, right? So in this case, we are saying this is our first node, second node, third node, fourth node. And we have simplified this diagram. Now we don't put the addresses anymore. In most cases, if not all cases, you never see questions where they put the actual addresses. This is usually how your diagrams will be when you start attempting questions or throughout the textbook. It will look like this, which means this node stores the address of this node, which stores the address of this node, and so on and so on and so on. And this is the info part. This is the link part. Info, link, info, link, info, link. Right. Now, there's something very important that I want you to realize in this diagram. We've got two pointers here. There's a pointer called head, and there's a pointer called P. P is a pointer pointing at this node. Head is a pointer pointing at this node. Now, I find this confusing. So if you've been with me or if you followed all our classes, you realize that I don't like drawing these diagrams like this. I normally just go 45, which is pointing at 65, which is pointing at 34, which is pointing at 76, like that. And I don't like these extra arrows that you see here, but you still have to understand this notation because that is what's usually used in exams and so forth. But what I normally do when I'm working out questions and explaining things is just write the pointer on top of the node like this, which means the head is the pointer sitting on node 45 or pointing at node 45. P is the pointer pointing at node 65. So we've got 4 nodes and 2 pointers. The pointers that we are looking at here are pointing at a node. which means if I want to refer to this node, I can use this pointer. If I want to refer to this node, I can use this pointer. So if I want to display the value of this node, I could do something like cout, then I say head dot info, like this. This would display the value of node 45. Likewise, if I want to refer to this node, I just use p. So I can say cout, then I can say p dot info, and I'll display info. Now the next question becomes, why are you saying dot and drawing this arrow here? This is basically just a hyphen and an angular bracket. That's your dot. Why is the dot like that? Because why isn't it something like p dot info? This is not correct. And why? So the dot that we see here is referred to as the dereference operator. What's happening here? So remember, p here is a pointer. So if we say p.info, it doesn't quite make sense because p is just an address. The value of your pointer p is simply an address. So the pointer head and the pointer p are just storing the addresses of these two nodes here. So if I want to display the value of p, we have to dereference the pointer, which means the right way would be to go cout, then I go p, but I have to dereference p. So I have to put an asterisk here. You know, you dereference pointers. Now I can now say dot info, and this would be right. Why? Because we have dereferenced our pointer, which means now we are referring to the value of the node. So this is the actual node. And now we can say dot info, because p on its own is simply an address. So this syntax is a bit clumsy, you know. So a shortcut to doing this is to simply go p dot info. So this operator here, you know, your hyphen and your angular bracket, allows you to dereference a pointer and then call a function or a value if it's a complex object like a class or a struct and so on and so on. So that is why it's referred to as a dereference operator, and we use it with complex objects like structs and classes. Like if you make a variable of a complex type and it's a pointer, now you want to say dot and call a function, like in this case it's a struct. You want to say dot info. It dereferences the pointer for you and then allows you to access the attributes. So you have to get used to this as your normal dot. Okay, so that's off the way. The next thing that you have to understand here is how your links work, right? So if I go back and we look at this diagram here, and let's quickly just simplify it again. So we said we've got our node 45, which is here, which is pointing at our node 65, which is pointing at our node 34, which is pointing at 76, like that. And this is pointing at nothing. We said this pointer head is here, P is here. The next thing I want you to also remember when dealing with pointers is that, remember, this pointer is linking to this pointer, which is to this node, which is linking to this node and this node. If you are here and you say head, then you say dot link. We've seen dot info. Dot info would give you the value of the node. If you say head dot link, you are now referring to the next node, which means head dot link is the same as P. These are exactly the same thing. So head dot link, which is this node, is the same as P. And you can also continue. If you go head dot link, for instance, if you do this, you are now referring to this node because it's like head dot link. So now that's 34. If I say dot link again, then I'm now here, right? So if I do something like head dot link, then I say dot info, and I say, let's say it's a C out. What is this going to print, right? Head, which is this node, dot link, which is this node, dot link, which is this node, dot info, we would print 34. So these are the basics of understanding how nodes work. Now, Linked lists, I always say that for you to fully grasp how linked lists work and understand the syntax, there are about 2 lines of code that I want you guys to never forget, okay? And I've said this so many times. If you've looked at our class videos, you should see that. If you look at the linked list videos, you should see that. But let's do a quick recap of what I'm talking about here, okay? Because you won't be able to move forward if you don't grasp these concepts. We said that whenever you're dealing with linked lists or pointers in a linked list, you have to understand basically 2 lines of code. And these are the most 2 operations you're going to be doing. The first operation is moving a pointer. And the second operation is linking nodes. Never forget these 2 things, because these are the most 2 basic things you are going to be doing every single time. Every single time, this is what you're going to be doing. Now let's go back to our diagram so that this makes sense. I'm going to put P here. I'm going to put head here so that it's clear, right? It's the same thing. I haven't changed anything. If you want to move this pointer P from this node to this node, the end result would look like this. You would have your P sitting here. That means we have moved P from here to there. So P is no longer sitting on this node. What have you done? You have moved your pointer from one node to another, right? So moving a pointer does not change the state of your list. You are simply changing the position of a pointer. You're simply changing the node which your pointer is pointing to, okay? And if we go back to our code, if you want to move a pointer, your syntax is going to be pointer equals, right? So if you go P equals, this means that you are moving P to whatever node you put here. So in other words, I'm saying pointer followed by an equal sign means you are moving this pointer to whatever is on the right, which means whatever node this is where your P is going. Okay, we're going to stress on this syntax when we start doing more examples. Like there's a very good example you can look at right now. But I want you to keep this in your mind. Pointer followed by an equal sign simply means your pointer is moving to whatever node is on the right. So if you see something like P equals Q and both are pointers, it simply means P is moving to where Q is. Simple. Okay. I don't want to talk about addresses and pointers. That's a subject for another day. That's a topic we can talk about separately. But when doing linked lists, you don't want to stress yourself too much with all the details about pointers and addresses. And now you are assigning an address to a pointer. Therefore, now they have the same address. Therefore, now let's just keep it very simple. Pointer equals, you're moving a pointer. The second common line of code you're going to see is when you link 2 nodes together, or when you link a node to another node. What do I mean? Let's say you have a node here, right? Let's say this is P. You have another node here. Let's say this is Q. The values don't matter, right? You want to achieve this link where P now links to Q. In other words, you have now connected P to Q. That's linking nodes. How do you achieve this? This is achieved by pointer dot link equals. P dot link equals means you are connecting the node where P is to whatever node is on the right, which means for us to achieve what we've just done here, we would simply say P dot link equals Q. This is how we achieve this state. Now this means we are linking P to Q. These are the most important lines of code that you should not forget. If you see these lines, you have to know exactly what's happening every single time. So there are going to be two cases involved. Number one, you are the one writing the code to do this, or the code is there. You are simply tracing or interpreting the effects of that code. Okay, so that is basically the most important thing you need to understand before you move on with linked lists. Just understand how the operations on nodes work, because as we move forward, you're going to realize that most of the linked list questions are just based on logic. Do you understand how to achieve what the question wants you to achieve, which is going to be the second part of these lessons. So the first part is just basically understanding nodes and how nodes work. The second part is let's look at the linked list type class and look at all those questions where you have to write the code. And you realize that for the most part, it's just the logic. The syntax usually boils down to these two lines of code, because moving pointers and linking nodes is what you are going to be doing a lot of times. There's also deleting nodes, but we'll talk about that. But for the most part, you are moving pointers and linking nodes, moving pointers, linking nodes, moving pointers, linking nodes. That is all you are doing for the most part. So you have to be able to look at this code and in your mind quickly understand what's really going on without stressing yourself with pointers and addresses and all the technicalities of what happens with pointers, right? Okay, let's jump into a few examples and see if we really grasp these concepts. So now the first example we're going to look at, these are all past exam type based questions. So it should really shed a good idea on exactly what we are trying to achieve. So this one says, what is produced by the following C++ code? Assume that the node is the usual info link form, which means they are saying, just assume it's the usual struct that we use where we've got info and link, nothing, special, the usual struct that info link. And it's of type int, Now, list and ptr are pointers of type node type. So we've got node type, which is the same struct that we've seen before, nothing special there. Now, your job is to execute this code line by line and then give the output for this code. Okay, I'm going to draw a line here. Oh, sorry. Because below this line, all that happens is we display. So we'll get there. So for others, what might make it easier is to actually, have a small diagram and use that to keep track of the status or the state of your list. So let's start with line number 1 here. When I just refer to them as we go. List equals new node type, right? New node type, you're creating a new node, okay? So we now have a new node here. And list is sitting on this node or is pointing to this node. Remember, the actual recommended way of drawing this would be to put your new node here, then you say list, and then list points at this node. But I don't like the extra points, the extra arrows. So I prefer to draw it this way to keep it simple. If you then want to draw, let's say they say draw the diagram. I normally do it like this first, and then you can do the extra arrows when you've got the final state of the diagram, because sometimes the extra arrows can be confusing. So I don't normally use this notation, which is the initial notation that we looked at, right? So here we are saying that list equals new node type. So list is now in a new node. List.info equals 20. Now we set the value of info to 20 because we're simply setting the info attribute, remember, which is the value, okay, to 20. Line 2 done. Line 3. PTR equals new node. Okay, we have another node called PTR, so we can do this. Here it is. Okay. Line 4 is done. Line 4 says PTR.info equals 28. So this is 28. Okay. Line 4 is now done. So just tick this as we go. Okay. Line 5. PTR.link equals now. Okay. So what you see? Pointer.link equals means you're linking it to a node. So we can just go, oops, points to nothing. Or just a down arrow, it's fine. So this is done. 6, list.link equals, what are you doing? We are linking list to PTR. So you're achieving this link. That's all you're doing here. So list.link equals PTR, done. Let's go to line number 7. PTR equals, what are you doing? Moving your pointer. So where is PTR moving on to? Oh, to a new node. So we can just make a new node here. Right now, you don't know where things are going. I'm just going to put them anyway here, which means it's no longer here. We've moved it, right? So line 7 is done. Let's go to line number 8. PTR.info equals 30. Okay, so we set this to 30. Okay. Number 9. PTR.link equals, again, PTR.link, pointer.link equals means you are linking to, equals list. So this is actually linking to list. Okay, done. Line number 10. List equals PTR. Oh, you see that? These are the things that confuse you. Okay, but again, 2 lines of code, moving pointers and linking nodes. List equals means you are moving list to PTR. So list is moving from here to here. So these 2 are now sitting on the same node because we've just moved PTR to list. List to PTR. Line number 11. Then we have PTR equals, again, we move it to a new node. I don't know where things are going. I'm going to put my new node here. Okay, it is now, which means we have moved it. It's no longer here. Okay, and we are done with this line. We are done with this line. Line number 12. PTR.info equals 42. So this becomes 42. Done. Line number 13. PTR.link equals list.link. Yay. You see, it's just, mind twisting lines of code. But otherwise, if you go back to the basics, what are we doing here? Pointer.link equals means you are linking PTR to whatever is on the right. We are linking it to whatever is on the right. So we are linking this node to where? To this guy. Wherever this guy is, that is who we are linking it to. So where is list? Now, list is this one. So who is list.link? List.link is this guy, which means we are linking PTR to this node because this is list.link. So in other words, this is linking to this node. Okay, and line 13, done. Line 14, list.link equals, where is list? List is here, didn't move. .link, pointer.link equals means we are linking this node to where? To PTR. Where's PTR? It's here. So this node is linking to this guy, which means this link is now changing and pointing there. I'm just going to erase it quickly. So we are removing this link here. And now it's going to point at PTR. That's line number 14. Line number 15, finally, PTR equals list, which means we move PTR to list. Where is list? List is here. So we move this pointer back to here, right? So let's just erase this part. And we are saying PTR is back here together with list, and PTR is no longer here. So what I did is executed these lines of code 1 line at a time, following basic principles based on my understanding of these lines. Pointer equals, I'm moving it. Pointer.link equals, I'm linking. That's all I've done. Whether it makes sense or not, it's not your problem. Just follow the code. Do what it says. Text practice, it's not that difficult because it's only 2 lines, 2 operations. Now, from line 16 going down, this loop here, we are now displaying everything in the list. But how do you know that? What's happening? If you're looking at this code for the first time, it means you haven't practiced enough because this is just a revision, remember. So we are saying as long as PTR is not equal to now, we are displaying the value of PTR and then moving it to the next node. What do you mean moving it to the next node? Well, because this says PTR equals, which means we are moving PTR to where? To PTR.link, which means to the next node. Because if PTR is here, then PTR.link is this guy. So we're going to move it here. Then we check, is it now? No. Okay, let's move it to this guy. Is it now? No. Okay, let's move it to this guy. Is it now? No. Let's move it to this one. Is it now? Yes. Then the loop jumps out. So What this loop is simply doing is moving the pointer forward until it gets to the end of the list. It's one of the most common loops you should be able to do, just looping through the list. Like, how do you traverse a linked list? You would use a loop that looks like this one. While pointer is not equal to null, then you do whatever you want to do with each node, and then at the bottom, you move your pointer to the next node. So basically what's happening here is we're going to start off with PTR, which is here, and we're going to say, is it now? No. Display info followed by a space. So we're going to display 30 followed by a space, right? Then we move it to the next node. So PTR is going to move from here to here. Then we display info followed by a space. Now we display 42, right? Then it moves to the next node, which means it moves to here, right? We display 20. Then we move to the next node, we display 28. Then it moves to the next node, which is now this now pointer here, and then the loop terminates, which means eventually this is what we are going to be displaying: 30, 42, 20, 28. And there's your answer, which is in this case A. So even though it's a multiple choice question, and it's only 2 marks, like in this case, it did take a lot of effort to actually get the final answer. But in these cases, you have to practice so that you move fast, because you should be able to do this in under 2 minutes. So that is basically what's happening in this question, which is a very good one for practicing your understanding of these 2 lines of code, which is your foundation to understanding linked lists. Okay, let's look at another example. Now, these questions are a bit different. They give you a list of nodes, and they want you to write the output of this code here. Okay. And remember, I don't like this notation. I pretty much just go P is here, Q is here, and I don't look at this completely. Okay, that's what I do. Now they say, what is the output of this code? And again, all you do is you follow the code line by line. While p.link is not equal to null, which means as long as p.link is not equal to this value here, which is the null value, then we should keep looping. So at this point in time, p is here. P.link is this node. Is this equal to null? No, it's not. Okay, what do? P equals, we move p to where? To p.link. See what's happening there? So you move p to p.link, which means in simple terms, we could simply say advance p twice. That is what this line is doing, which means after executing this line, your p is now sitting here because it went p.link. Then what do you do after that? Q equals, or we move q to q.link. In other words, in simple terms, we would simply say advance q once, which means your q moves from here and your q goes to here, because I'm following the arrows. Remember, this is from here, there you go. Then that's the order for your nodes. Okay. Then what do? See out q.info followed by a comma. Then I display the value of q followed by a comma. So in this case, I am displaying 50, comma. Then I go back to my condition, right? And I repeat the same process. Is p.link equal to null? Where's p? P is here. P.link is this one. It's not equal to null. What do? Advance p twice. So p is here. So it goes here, then here. So my p is now sitting here. Q advances 1, so Q is now here. Then I display the value of Q, which is now 24. Then I go again. Is p.link equal to null? P.link is 60, so no. What do? We advance P twice, so P moves from here. And then P is now here. Q advances 1, so Q is now here. What do? We display Q.info, so we display 60. Then we go back to our condition. Is Q.link equal to a null? P is here. P.link is this guy, which is a null value. Our condition becomes false. because p.link is actually not equal to a null. It's actually a null value. Therefore, your display is going to be these three numbers, 50, 24, 60. Just basic understanding of how your nodes work. Okay. Here's another example. Again, same list, different code. Why would p.link is not equal to null? So your p is here. Sorry, your p is here. Your q is here. Don't look at this, right? What do we do? P.link is not equal to null. Yeah, of course. This is the same question. Sorry, this is exactly the same question. Let's go to the next one. Now this one says, yeah, that's a different question. So let's go, P is here, Q is here. Let's forget about that. I don't like this notation. While Q is not equal to a null. So Q is here. We are now looking at Q. Is it equal to a null? No, it's not. Okay, so what do we do? P equals p.link. In simpler terms, we could simply say advance P once, which means P moves from here to here. See out q.info, display Q, which is 25, followed by a comma. Then we go to the next line. Q equals p.link, which means you are advancing Q to the second node from P. See that? Q is moving to where? To p.link. If P is here, p.link is this node, which means your Q is advancing to this node as it is. So Q goes to this node from here. Then we go back, we check our condition. Is Q now equal to null? No, it's not. We advance P1, so P goes here. We display the value of Q, which is now 50. We advance Q to p.link, which means if P is here, p.link is this guy. So Q advances to this node. Therefore, Q is now there. Is Q equal to null? No, it's not. We advance P1, so P goes here. We display the value of Q, which is 24. We advance Q to p.link. Therefore, our Q is going to p.link. So our Q goes to 60. All right. So Q advances from here to here. We check our condition. Is Q equal to null? No, it's not. So therefore we advance P once. So P moves from here. P goes here. We display the value of Q, which is 60, right? Then we advance Q twice. Q becomes p.link. So Q becomes 70. So Q advances to that node. So Q moves from here. Q is now there, right? And then we check our condition. Is Q equal to a null? No, it's not. Therefore, we advance P once. P moves to here. We display the value of Q, which is now 70. And then we advance Q to p.link. Now P is here. p.link. Therefore, our Q becomes your null value here. So Q advances to here. We go and check our condition. Q is now equal to a null value. Therefore, we terminate. And therefore, our output is 25, 50, 24, 60, 70. There we go. That's it. Line by line as you see it. That's all you do. Let's go to the next example. This one, again, same thing. So we've got P sitting here, we've got Q sitting there, and we've got list sitting here, right? Which of the following relational expressions will return the value false? Interesting. So let's start with the first one. List.link.info is equal to 23. List.link.info is 23. Yes, that's true. List.link is equal to p.link. List.link, which is this node, is equal to p.link, which is again this node, which means yes, that's true. P.link. P.link, link is Q is equal to Q link. Definitely not, right? Because these two are not equal, because P link is actually this guy 3 times. Okay, so let's hold on to C. P link info, that's 23, is less than Q info, 87. That's correct. Q link, Q link. So remember the last link would be your actual null value. So we are going Q link, which is this node, link, which is this node, link, which is your null value, is equal to a null value, which is true. Therefore, indeed, we only have one wrong answer, which is then C. All right, next example. Which of the following statements will cause P to point to the node containing info 23? We want P here, right, to point to the node containing info 23. In other words, we want to move P so that it's here, because then P is pointing there according to this sort of way of drawing things, right? So how can we, in other words, move P to the node containing info 23? Moving a pointer equals this node. What is this node? This node is p.link. So you can just go p.link. And remember, this node is also list, link. Both can do. So we can either say P equals p.link or P equals list, link. These two are equivalent. Now let's look at the answers. Which of the following statements will cause P to point to the node containing info 23? So P equals p.link, correct? P equals list, link, correct? P.info equals 23. No, this simply changes the value of the node P to become 23. Wrong. A and B, yes. A, B, and C, wrong. So your answer becomes D. Because both A and B are correct. Right. So these things just need you guys to keep on practicing. Okay, I think should maybe do one more example with you guys, but this would be the last example. Let's look at this one first. I think this question is very similar to the other ones we've done before. If you find problems with this one, let me know, and we can look at it. But let's look at this one first, and then we can come back to it. Consider the list below consisting of 2 nodes of integer type, node type, and a pointer P, pointing to the first node. So P is here, that's what it means. Provide the code that will insert a new node with value 43 after the node with value 32. So in other words, we want to insert a value, a new node with info 43 after this node. So after everything, we want our list to look like this: 32 pointing at 43, probably pointing at 87, which is now nothing, or just pointing at nothing. So this is here our new node. What lines of code do we need to write to achieve this? Becomes the question. Okay, so this question is a very good foundation for our next, type of questions that we need to look at, because it allows you to build the logic, understand exactly what you need to do to achieve this status here. So if we look at this, let's just move this, downwards and see what we can, let's move this downwards here. And then we'll work our way to this. And then let's erase this actually, because we've got it now. So you can start by saying the first thing I want to do is to introduce a new node. So number one, you can say introduce new node. And I'm going to draw it here. So we put our node here. And let's assign it maybe a pointer called temp. And assign to temp. Right? Now, the challenge here, I want to show you something that might break your logic. Let's say in your second step, you say link P to temp. That means you break this link and you link it to your temp. Now, the challenge with this is number 3, you would then want to link temp to this node here. But how do you do it? Because you have no way of accessing this node. The only way of getting to this node was to actually go p.link. You see that? So before you break this link, you want to keep this address somewhere, which means you might introduce another pointer that stores this node for you. Therefore, it's wiser then for step 2 to then be something like assign node 87 to whatever you call it, temp 2, right? So this becomes temp 2. Then my third step can then be link P. I can then say here link P to temp. So here I can go link P to temp. So now I can break this and link P to temp. And then finally, I can then say link temp to temp 2, which means I now take this and I connect it to that node. Now I have achieved this. So you see, it's exactly 4 lines of code. What matters most is that I got my logic or my pseudocode right. It's more like you're playing a game of nodes, pretty much, because it's very crucial for you to understand how do I move away from this current state to the next state, because the next type of questions we're going to be looking at are based on this idea of logic. Do you understand what you're trying to achieve, and how do you achieve it? So if we then have to write the code, we can just replace these 4 lines of code, literally with just in these 4 lines here in our pseudocode or in our logic with just 4 lines of code. Number 1, introduce a new node and assign it to temp. We can just say node type of type int. We can call this one temp is equal to new node type, new node type of type int, like this. So definitely we know that this has been done. We now have our new node, which is temp, right? Second step is now assign node 87 to temp. So I can say, well, let's make another node type of type int. Let's call this one temp 2 equals, what is 87? It's p.link, right? So it equals p.link, which means our temp 2 is now here. And we've got our temp node sitting there, right? Now, step number 3, link P to temp. One of the steps we left out here that you might want to do is to assign the value 43 to your node. So you can just say temp.info is equal to 43. You can do this line here if you want, just so that you do it together, right? Then the next thing is we want to assign node 87 to temp. We've done that. Then link P to temp. So P should now link to temp. How do you link nodes? It's pointer dot link equals, you're linking it to temp equals temp. That line is done. And finally, you link temp to temp 2. How do you link nodes? Now you go temp dot link equals temp 2, and your code is done. Only that here, you're not seeing the diagram, but if we step through this line by line, now that we can see the code, just to confirm what we've done here, it's exactly what we agreed. So you start off with your nodes, 32 sitting here with P, which is pointing at your node here, 87. Line number 1, introduce a new node called temp, right? So I'm introducing a new node here and calling it temp, right? Line number 2, introduce a new pointer temp2 and move it to p.link, which means temp2 is now here, done. Temp.info equals 43, okay, I'll make this 43, done. P.link equals temp. P.link, you're linking node, which means you're saying this link is now here, done. Temp.link equals temp2, so temp is now there, which means we've introduced a new node, and now we've got 3 nodes, 32, 43, 87. All right, so you can go ahead and practice most of these questions on your own. Maybe let's just look at this one just to finish all the questions in this slide. This one says, here's your pointers, your P is here, your Q is there. What is the output of this code? So we start off by saying, is P equal to a null value? No, it's not. Okay, display P, we display 32 and the space. We move P, we advance P twice, which means we keep on advancing P twice. That's it. So P moves from here, P.link, so P comes here, we display it, becomes 43. We advance P twice, so P moves from here to here. We display this becomes 25. We advance P twice, so P moves from here to here, then from here to your null value. And then your loop terminates, which means you have only displayed 32, 43, and 25. That would be your answer for that one. Okay. So I hope you have fully understood how nodes work. You have to keep on practicing these questions and get to fully understand how to work with nodes, because it's very crucial for you to understand how nodes work or operate before you can attempt the next type of questions that we deal with on linked lists, which is the linked list type class-based questions. Okay, but for now, you have to understand nodes, practice, and then we can look at the more complicated questions on linked lists, which is the ones based on your linked list type class. Otherwise, that's it for me for this one. I'll see you in the next one. Cheers.